Hello everybody, we are now doing an example about a cone with water in it and it is leaking. The first step they did is draw the picture, which was on the previous slide. I'll show you in a second. We are now finding our unknowns and knowns from this problem. That's my picture. Okay, ready? Okay, who's up first? Let me pick a card. Kristen. What is a known or unknown? Anything you want. We know the radius. Okay, so radius is what? 5. Okay, good. Stat, what else do we know?
We know that the depth of the water is at 6 feet.
Okay, depth of the water. So how would you write that? 6 equals what?
H.
6 equals h. That's what I would have written. Hunter, what else do we know?
dr dt is negative 2p.
Okay, you said dr dt. What do you want r to?
dh dt.
dh. So what do you want h to be representing?
The height of the water.
Height of the water. So your height of the water is cubic feet.
No, it's the volume.
It's a volume.
I put v2.
Okay, so you got to be careful with that. Unknown, we don't have the unknown yet. Reba, what's the unknown, the thing we're trying to find? The rate of the depth. So how do you write that? Something equals question mark. What? dh dt. Those are all things you need to know. Now, I didn't write down the r is 5, and I'm going to show you why in a second. Because it is kind of important to this problem, but the radius of 5 is the cone. It's not the water portion. So that's important because that water portion changes. So these are the 3 things that are important. And I did show a little new notation here, but we've done it before. I did a dh dt, but look at that, I decided to do v prime instead of dd dt. Doesn't matter. Okay, questions so far? Okay, Mike.
Why didn't we use 14?
Okay, we didn't use 14 and 5 yet, because here's why. Everything we're dealing with in this problem is about the water. Okay? So this is my water right here. Let me change, oh, it is blue. This is my water. Is it really going to be 5 and 14 throughout the whole thing?
No.
That's only when it's full. This is changing. Is the height changing?
Yes.
Is the radius changing?
Yes.
Here's a very important fact. Because the radius is changing, you cannot plug in 5 right away. And because the height is changing, you can't plug in 14 right away. Plug it in for what formula? I don't know. Write the formula. Go! And as soon as you get the formula, differentiate. It's on your sheet. I hope. Make sure I got it there. Yep, I see it. Formula. After you get the formula, differentiate. Why'd you plug in 6? Yeah, but the h is changing. You can't plug it in until you're done. So don't plug in that 6. Leave it as h. Differentiate. Got 2 variables. How do you differentiate 2 variables? No. Derivative. How do you derivative when you have 2 variables? Come on, Ryan, advance the inquiry here. You should be on the top of your game today. It's been weak today.
Good morning. Good morning.
Oh.
Would you write your formula? Where's your formula? Okay, it's 1/3 pi r squared h. 1/3 pi r squared h. No, let me see formulas.
Come on. Are you
Okay, nearly the entire room is forgetting the product rule.
Dang it. I'm going to do it. I'm trying to avoid it.
Product rule because there's 2 different letters and you can't plug in the letters until you're done. Until you're done with the derivative. Here is the formula.
I didn't do the product rule.
Okay, and you did do the product rule. First time to the second plus second time to the first.
Nope.
Okay. That's why we worked long and hard on the product rule versus not product rule versus chain rule versus quotient rule, is so that we didn't have that issue here. But some of you still do, it's like
I'm
having an
sure
algebra
it was,
issue.
right? It was theirs.
Okay. Eventually you'll get that. Now, R primes and H primes in the problem represent dH dt, dr dt, and V prime is dV dt. So I'll just use primes for now because I like them. On this problem, I usually probably don't on my papers because that confuses me sometimes. Sometimes I think it's a 1 and I get messed up and I think, oh, R times R to the 1 is R squared. Be careful there. I kind of prefer dr dt's, but I copy this from the internet and they use the primes.
First times we were second.
Okay? So yeah, let me run through that in case if you need it. The first, this is my first. So they actually do it backwards. The first is right here, times the derivative of h is h prime. So this right here is first times derivative of second. And I should have put a dt, not a dx. And then this is the second is h. Times the derivative of the first, which I'll call 1 prime. Okay, now don't forget, the 2 comes in front to make 2/3. You lower the power to r to the 1, which is right there. And then, because it's an r, you need an r prime. Okay, now, no big deal, huh? So I start plugging in things and solve. So I'm going to plug in my 2 for dv dt, but I'm going to run into a problem. What's my problem?
Should it be -2?
No, negative, why?
Because it's coming out.
Oh, negative.
Oh, is it leaking? Yes.
Yeah.
Oh, yeah.
Oh,
Uh-oh.
yeah.
Negative. You're right. Okay. I'm sorry. Now go back. What's my problem with this whole formula?
We don't have radius.
Yeah, you don't have a radius of the water part of the cone, and you don't have a what else? An r prime. You don't have the rate of the radius. By the way, that's the second question. Rate of the radius. You don't have 2 things. How can you solve a problem without 2 things? That's why the cone and the trough and the lamppost problems are harder, because you have to use similar triangles. So let me pause for a second and fix this problem. Here is how I'm going to fix it. This is new, so I'm teaching you something today that's on the first problem. So here's what I do. I write this. And what the heck is this? This is biggest cone. Let me change the thickness of that. Biggest cone. And then I'm going to overlap that with blue water. Here's my blue water. Can you see that these triangles are the same? They're similar, not the same. They're similar. So now I'm going to kind of say that the big one, the black one, has a units of 14 for height, 14, and a radius of 5. So I'm going to kind of highlight those, radius and height of this triangle. Yes?
Could you put in 6 for, could you put 5 over r and then 14 over 6?
Yes.
That would give you a different answer.
Would it?
All times by 6 now.
Hold on, let me put in the letters before I do that. Let me go to the blue. So I'm going to go to the blue, and the blue is the radius of my blue is I don't know. My height of my blue is I don't know. Yeah, it's 6, but it's still changing, so I never put it in until after I take the derivative. So it's h. So these are my similar triangles. Radius to radius equals height to height. So you have a couple options here. You could have done radius to height, or you could have done radius to radius equals height to height. So that's your other option, Stan. Either one of those. So I don't know if you said that or not.
So I can't put 6 in for each?
No, you cannot put 6 in for h because 6 changes. Never put in 6 before you take the derivative. Never put in 14 on this problem before you take the derivative. That's the tricky part of these. Now, you have to solve for one in terms of the other, so it's cross multiplication. Either one of these. So 14h is 14h, or r, sorry, thank you, and 5h is 5h, and I solve for one in terms of the other. So they chose to solve for r and got it in terms of h. This is important because you could have done h equals 14/5 r. What do you want, bless you, in your problem? Do you want h's or do you want r's? Why do you want h's?
Because H is given.
Because h is given and
Because that's what
because that's what it's
it's asking for.
asking for. Yes, it's asking for h prime. Don't get rid of the h's because you won't have h prime. So that's the tricky part of that question. So now I'm going to finish part A by, oh god, I had more on that slide. Watch this. Old formula, 1/3 pi r squared h. New formula.
So you just plugged it into those things.
Yep, all I did is took out this r squared and replaced it with this. The reason I do that is because now I'm r-less. I only have a function of h.
You're no longer a
It's true. No r.
That's depressing.
This is not that difficult, you guys, because they're always done the same way. If it's a lamppost problem, if it's a trough problem with a triangle, whenever you see a triangular shape, it's likely to be similar triangles and this stuff here. I don't know why students make that difficult. It's not, because they're always in the same problems.
So we don't
Can
have
you
Oh,
to take
figure
the
that with
derivative.
H in there?
No, because
Taking the derivative.
Oh, you just, okay, I see what you're saying.
yeah, this is what r is, so that goes right in for r, and then it becomes squared. Don't forget, you gotta square both the 5, the 14, and the h.
I'm
So-
saying H after, but
Yeah, and then the third gets put together in there too. So really, that numerator right there is 1 times 5 times 5, because that's 5 squared. The denominator is 3 times 14 times 14. That's how you get 588. Now you're ready. The problem is easy. Take the derivative. This is what v equals.
H.
Well, that's what v equals.
Oh.
Now you take the derivative, you plug in what you know, you plug in what you don't know, and you solve. Go. Don't forget, 25 5/88 pi is the coefficient. Yes, Elsa?
Why do you plug it into the original one again?
Because you don't want a function of r and h, because when you differentiate it, you got r primes and h primes. You only want to get the prime of the letter you're looking for.
But we can still solve for our prime.
You could, and there's an alternate way to do this, but it's a little more complicated that way. Because if you solve for r prime, then you have to go back and solve in this problem to get r prime in terms of h prime, and then you plug it in. It's a lot harder. Not understand what I'm saying? Don't worry about that yet, okay? Because I've only got 3 minutes here, so I got to crank this up. Here's the derivative. Did you remember your h prime? Now your depth of the water is 6 feet. You plug in your 6. You plug in your 2. And I don't know if they use -2 or not. Oh, they did. They had the 2, but then they used -2. And then here's your final answer. It's a really easy problem once you get that similar triangle stuff out of the
So
way.
doing the derivative first was useless.
Doing the derivative first was useless, and I would have not used the derivative first. But I don't know if you would have realized why you didn't use the derivative unless I showed it to you, that there's an r prime in there that you don't know also. Now, if this thing told me the rate of the radius change, you could have used that. But it didn't give me enough information because it left me with 2 unknown things. So when you do the first problem on today's homework, don't take the derivative until you eliminate one of the letters. The problem you're doing, the first one, is almost identical, just different numbers. Okay, so I just want to see if you can do this again, and then I'm going to morph you into harder ones, like the trough and the lamppost and the ladder sliding problem and so. Any questions? I mean, either one of these is fine because they're exact or approximate. Plug in your 6, plug in your -2, divide everything to get h prime. By the way, this is just gonna be really fast. What rate is the radius of the top of the water changing when the radius of the rate of the radius? Watch how easy that is. When you got this formula, you just take its derivative. You plug in your h prime from the last question, and then that's your answer. You can use any formula you come up with to solve for it, so you don't have to go back to the original. You could go back to the whole product rule original if you wanted to. Okay, that's it for today, ladies and gentlemen. Thank you for coming. I'm going to give you a worksheet in a second after I stop.